Okay. 8M3 lesson 14. After today, we will be halfway done with the Eureka Math 8th grade lesson set. Figuring Unit 3 is halfway done. So today we're going to talk about, again, lesson 14, the converse of the Pythagorean theorem. Hopefully this is not I think this is a relatively easy topic, but what I'll do is I'll go over the concept really quickly, and then we're going to do 3 homework helper problems, and then you'll be ready for your 8M3 test, and we'll move on to 8M4 next time. So let's get moving on this, and let's cut over to our sketch pad where we're going to do all of our work today. Okay, so here we go. The converse of the Pythagorean theorem. Let's go back now we're going to go back and do a review. This is lesson 14 today, but we're going to talk about lesson 13 just to connect and then move forward. So lesson 14 says that if we have a right triangle, if we have a right triangle that looks like this, where A is a leg, A and B are legs, and C is the hypotenuse, right? So C is the side, right, opposite, the hypotenuse is the side opposite the right angle. That's important. Always the side opposite. If this is all set up for us, then A squared, or A, which is equal to the length of one leg, and B is equal to the length of the other leg. So A squared, you got to square that side, and B plus B squared, the length of the other side, is equal to C, the length of hypotenuse. Right, and this is important. Some say this is the most important theorem or formula in geometry. Some say, and it's definitely arguable, and it's probably true. I don't want to get into arguing that there's maybe other ones that are more important or equally important, but this is everyone would agree that this is at least very, very important. Okay. So that's lesson 13, and we proved this using similar triangles. We also proved it using other forms of geometry back in 8M2. So we've proved this 2 ways. And why did we prove it 2 ways? Because it's really important to get a good conceptual grounding in this theorem. Okay, so let's go forward, and now let's do the converse. We're not going to prove the converse of the Pythagorean theorem, but we're just going to state it. We'll state it in, well, this color. Can we see this color? No, we can't see this color. I've never used like that. No, I haven't used that color. Let's use a new color I've never used before. Somewhere up in this range. Maybe this one. Yeah, let's try that. Okay, the converse of the Pythagorean theorem is this. It says that if A squared plus B squared does not equal C squared, where A and B are the shorter 2 sides of a triangle, and C is longest side, then the triangle is not a right triangle. right? So in lesson 13, we start with a right triangle, and then we end up with this statement. The converse means the opposite, or kind of, not necessarily the opposite, but it means a contrary, it means another direction. So in this case, we kind of start with the end in mind. We start with a squared plus b squared does not equal c squared. Here we say if it's a right triangle, then this is true. Now we say, well, what if this statement is not true? If this statement is not true, then the triangle is not a right triangle. So let's look and see. We'll do it in a different color because this yellow might be a little bit hard to see. We'll go to orange. And we'll say, we'll see whether this is a right triangle using this converse of the Pythagorean theorem. So let's see. What is our short sides? Our short sides are 4 and 7. So let's say 4 squared plus 7 squared. Now let's see if that's not equal to c squared. Let's see whether it's equal to c squared or not. Now, if it's equal, then it's a right triangle. But if it's not equal, if it is not equal, then it is not a right triangle, right? So let's do the math and let's see. Well, 16 plus 49, is that equal to 81? Well, 16 and 49, 16, 49, 5, 4, 95. Did I do that right? 5, 1. Oh, I can't believe I did that. Carry your 1, 65. So 65, is that equal to 81? No. 65 does not equal 81. So 4 squared plus 7 squared does not equal 9 squared. So no, this is not a right triangle. No. Put a big box around it, and I am going to give us a happy cat because this is the entire lesson. This is the entirety of the lesson. Perform this calculation, 2 short sides, square each side, add them together, take the sum. Does that equal the long side squared? If so, it's a right triangle. If not, it is not a right triangle. Now, let's cut straight to the homework help, and then we'll be done on our way, on our weekend, whatever we want, wherever we are headed. So let's write this down. This is homework help. Homework help. Homework help. Homework help. Okay, so let's solve these problems. Now your job is to look at these 3 problems, pause, and try. Okay, now I want you to pause and try all 3 of these. Now in 2 of these, we're trying to kind of, this first one, we might be trying to trick you, be careful. In the second one, I'm trying to ask you the question, and I want you to figure out whether this is true or not, and then to identify what mistake might someone make when answering this question. What mistake might they make? And then on the third, I just want you to answer, is this a right triangle, why or why not? And I want you to use what we just learned on the prior slide. So let's pause and try. Pause. Use that pause button, the one that looks like this, it's filled in, pause. Okay. Now I assume you're back. I assume you're back. Now let's look at number 1. What did we do wrong here? Well, let's look and see. Well, which is the long side and which are the short side? So if those of you who identify that this is the long side, so this should be C, and this should be A, and this should be B, or this could be B and this could be A, doesn't matter. The problem is, I think you might have figured it out, is that we took this C and we put it here. That was our mistake. Putting it here. What we should have done was we should have put the 35 on the outside because that's the long side. So we should have done 21 squared plus 28 squared and asked if that's equal to 35 squared. 21 squared is 441. 28 squared is 784. And is that equal to 1225, which is 35 squared? Well, 441 and 784, if you line them up and add them down, that does in fact equal 1225, which equals 1225. So in this case, is true. A squared plus B squared equals C squared. So this is indeed a right angle. So the answer is I was wrong. This is wrong. This was invalid. A squared plus B squared equals C squared. So here was my mistake. Hopefully you caught it, and we will give you a happy cat for catching it and saying, yes, yes, it is a right triangle. Or no, my math was wrong. This is a right triangle. Okay, so now let's look and see if this is a right triangle, why or why not. We'll stick with this, our solving in this color. So we take our short side, A equals 4, B equals 5, and C equals 9. 9 is our long side, and say, well, is 4 squared plus 5 squared equal to 9 squared? Wow, well, that looks like it might be true, but careful. 16 plus 25, does that equal 81? Well, 16 and 25 is 41, equals 81. My question marks here, and the answer is no. 41 does not equal 81. So the answer is no. This is not a right triangle. And notice, what is the problem that now what mistake, let's answer this second question, what mistake might one make when answering? Well, I think there's probably more than one answer, but the one that I see that jumps out is someone might say, oh, 4 squared plus 5 squared equals 9 squared. They might just look at this and say that that's true. Because 4 plus 5 equals 9, they might say 4 squared plus 5 squared equals 9 squared. And that is not true. You cannot say that. You can't just add squares like that. It doesn't work that way. So that is the mistake that one might make when answering this question. Okay. Now the final question is this a right triangle, why or why not? We're just going to go through the calculation. This is an easy one. It's not trying to trick you. It's giving you the opportunity to answer. And so we're going to put our A here, and our B here, and our C here, and we're going to run our calculation. So is 8 squared plus 15 squared, does that equal 17 squared? Well, I don't know. This is going to be a close one. Could go either way. 64 plus 225, does that equal, well, 17 squared? I don't know that one. So let's do that one like this. Well, 7, 9, 4, 11, 770, 989, 289. Does 64 and 225, let's add them together, 989, 289. Question mark, question mark. Well, 289 equals 289. So the answer is yes. And where does our right angle go? It goes opposite our hypotenuse. So this is our right angle. It's always good to label that guy. All right. Well, that was a relatively short lesson relative to the other ones that we've done. And hopefully this was useful. You know, it is pretty powerful. Pretty powerful indeed to be able to show triangles being right triangles or not just by squaring and summing the short sides. And you're now done with ADEM 3, so I'm going to give you a clap. Congratulations to you for watching and listening. I hope these lessons are coming through. If they help you, tell your friends about it. Do a like for me on YouTube. Send me a comment. Subscribe to the channel. Again, tell your friends about it. And I'll do more. I'm getting more and more traction. More and more people are watching the videos, and that makes me feel good. It makes me want to do more. So again, and if you need any help, if anyone needs any help on the test coming up, if there's some problem that the teacher asked that I haven't covered, and you want to say, how do I do this one, Mr. Lipscomb? Send me a note, put a note on YouTube and say, hey, Mr. Lipscomb, I need some help. Do a video that shows me how to prove something, a video that shows me how to do a tricky problem. Give me the page number, give me the problem number, send me a screenshot, and I'm happy to do that work for you. Also, if there's some problem that's not related to any of these subjects, a math problem you want me to do a video on, I can do that. I help kids out in calculus, pre-calc. I love doing math of all kinds. If there's some puzzle, you say, hey, Mr. Lipscomb, let's do a puzzle every once in a while. We can do that. I might just do another video with an interesting puzzle just to see who watches it and see who engages in it. I'm going to do that now. In fact, I'm going to do that as like a bonus, an ADEM 3 bonus question. Wow. And it will involve all the building blocks that you have up until now, and it will involve the Pythagorean Theorem. I'm going to do that right now. All right, over and out. Talk to you later. Hopefully you log in and watch my puzzle.